we are doing lesson 36, and this is Algebra 2. Let's look at contrived problems. In math, they give us problems that work out good and nicely and pretty, and mathematicians do that. So later on, when we use this mathematics, we use it in chemistry and physics and a bunch of other higher math. So it's important that we understand how to do the process. So when we're doing problems right now, the problems are usually contrived to be very practical, and that they're easy and they're pretty numbers usually. So let's go straight into rational expressions. When we multiply a fraction, right, we basically do numerator times numerator over denominator times denominator. Then we simplify. We can do the same thing if I have x over y times m times y plus k. It simply becomes xm over y squared plus yk. And basically we just did this times, because remember, this is enclosed by parentheses, so we have to, when we multiply, we have to distribute that y through every term. Alright, so we can do it with numbers and we can do it with variables. When we see a fraction, it's also understood to be a ratio, 3 to 5 or 3 out of 5. And that's the reason we call fractional expressions rational expressions. So this is a rational expression and this is a rational expression. So it's just good to understand the names and why they're called what they're called. Okay, so let's look at a problem. We've looked at simple problems for multiplying fractions. Let's look at one that's a little bit more complicated. Okay? So this means multiplication. So I've got, it looks very complicated, but basically it's just two fractions times each other. So what are you going to do? You're going to do numerator times numerator and denominator times denominator. That'd be a really complicated, who's got trinomials that you're multiplying by, and you can do it. Then you've got to go back and factor it to reduce. So the first thing we want to do is we want to factor out each polynomial, each trinomial. So this becomes x minus 4 times x plus 3. And we have to go back to how do we factor each one? X, let's see, times minus 5 times x plus 4 times x minus x plus 7 times x minus 5 over x plus 7 times x plus 2. Okay, and that's for another lesson. If you're having trouble factoring, let me know in class and we can go over it and we can stop and do this process. But right now, for this lesson, we're going to continue. So now that I've factored, since I have parentheses and I have multiplication going on, now if I have anything that's the same, it can simply reduce or cancel out. So this right here can cancel. Let's see, x. Oh, I have this wrong. X plus 4, x minus 3. I knew that was wrong. Okay, so this cancels out. My x minus 5's cancel out. And what am I left with? I'm left with x minus 3 over x plus 2. Very simple. So it's easier we factor out first and simplify and then multiply what's left versus trying to multiply a trinomial times a trinomial and then going back and combining like terms and then trying to factor this big trinomial and then going, because you still have to simplify and reduce. Okay, so now let's look at division of rational expressions. And we just did this. K over P. We said we have a fraction here. We have a fraction divided by a fraction, or we could say we have a big fraction with a complicated numerator and a complicated denominator is another way of thinking it. And we said one way to make the denominator 1, because we make it 1, then we get rid of it, because anything divided by 1 is itself. So it's to multiply by its reciprocal, but remember we said what we do to the numerator, we must also do to the denominator. So this cancels to 1, and you're left with x over y times p over k. And we said in class, the original problem, or I've mentioned it before, says the numerator divided by the denominator. So I can rewrite this to look like this, because that's what it says. And how do you divide fractions? Well, it's got to be shaped first, meaning it has to be a proper or improper fraction, and it is. There is no mixed number or whole numbers. Then I keep, change, flip, change the sign, flip the fraction, then I multiply. Then it's simply multiplying. And I get xp over yk. Okay? So, now, why is that important? It's important because now we're going to have a complicated. So let's look at example 36.2. You have x squared minus 6x plus 8 over x squared plus 3x minus 28 divided by x squared minus 2x minus 15 all over x squared plus 2x minus 35. Okay, it means divide. How do you divide? You're going to keep, change, flip. So x squared minus 6x plus 8 times x squared plus 2x minus 35 over x squared minus 2x minus 15. So now I'm ready to multiply, but I want to factor. So I'm going to cheat here for time-wise. X minus 2 times x minus 4 over x plus 7 times x minus 4 times x plus 7 times x minus 5 over x minus 5 times x plus 3. Now anything that's alike, you're going to cross out. So this goes away, this goes away, this goes away. And I'm simply left with x minus 2 over x plus 3. Okay. Now, so to simplify, when you've got divide, you have to remember you've got fractions. How do you divide fractions? You've got to shape it, meaning they have to be in fraction form, either a proper or improper. You cannot have a whole number next to it, or we can't have divided by 5. Or you can't have this divided by that. Because if you have it just like that, that's considered a whole number, and you need to change it to improper fraction by putting it over 1. Once it's shaped, then you keep this as is, you rewrite it, you're going to change the sign, and you're going to flip this over. So then this will become 1 over. Right? So you can't forget how to do simple fraction problems. So do your practice problems A and B, and we'll see you in class.